last quiz. Last quiz, I gave them much simpler than that, but the system was indeterminate. Everybody understand that. So what I'm saying that if you forget about this M here, then the system become pin and pin, then it become determinate. Is that correct or not? That's not the idea here. At least 1/3 of a student made that mistake, which I said you are not supposed to do it, and they use the static to solve the problem. Of course, if there is no M here, you have RA and RB, everybody can solve that. Is that correct or not? Yes? That means it's determinate, but you cannot change that process. That's a very, very, very bad mistake to make. Everybody understand that. This is an indeterminate problem. We want to use the double integration method because these are simpler load. The direct method is when the load become much more complicated. Everybody understand that. However, in the book, as we were discussing it with you and somebody else, in the book they write even W for this, which is not required. But then they go to negative. It's not required. In M, remember what we did. This is the key. If you have here, let's first of all put the support out and replace it with the reaction. Yes or no? We have here a reaction of RA. The magnitude is not known. Is that correct or not yet? Because the static doesn't work. Remember that. Here we have a reaction RB. Again, I don't know that. If you draw your free body diagram like that, everybody can see. That's what I was talking earlier. Is that a couple of minutes ago? That means it's solvable. Everybody understand that. You cannot make that mistake. You have to put a moment there. Yes or no? The moment, you don't know which way it goes. I know by practice, by experience, but you don't know. You draw it any way you want to. You can put it this way or the other way. Is that correct or not? Let's change this time and put it this way, which is statically positive. Is that correct? Also, moment white is positive. Is that correct or not? So I'm putting MB there, positive, as far as deformation. This is RB and RA, as far as all of them statically and deformation-wise are positive. Is that correct or not? Yes? All of them are known, cannot be done by static alone, never done before, so you shouldn't do that. Then we have to use the technique first to calculate RA, RB, and MB. So to do that, we have to go through deformation method. That's what we are doing now. Is that correct or not? So deformation is like that. EI, this is the equation of elastic curve before we do the integration. This is, we call it differential equation. EI d2y dx squared for this problem, of course, will be equal to m as a function of x. The question is, what is mx? So we have to write mx. Now, here is what you know or what you should know, let's put it this way, from ME218. Is that correct or not? After going through ME218 with lots of shear and moment diagram, after going through earlier all the problem I gave you at the beginning up to now, you should be able to look at the system, decide what kind of moment you have there. Now, I have a little bit problem with that one, or some of you may have, and those are when you could not draw, a few of you, draw the moment diagram for a simple beam, it will be difficult to know what we are doing here. Is that correct or not? I hope by now I have answered all your questions there. So here all we have to do, notice, as the result of this road, magnitude doesn't matter. As the result of that road, the moment here will be RA times X. Is that correct or not? The only question is if it is going to be RA times X, granted X is not, RA is not given, start at 0. The only thing is what kind of bracket do I have? Do I have 0 or 1? Everybody should know that the answer is 1 because linear. Yes or no? As the result of RA, you get a, here you get, we had done this in the past. There is no load between. The shear is constant. The moment is linear. So it goes to the power of 1. Yes or no? Now, what is this moment? What kind of moment this creates? Everybody knows the result of that is a parabola. Yes or no? The only thing is the sign. The parabola goes like this. W, which is 2, x minus 0 to the power of 2 over 2. Is that correct or not? Yes, you have done it many times to recognize that. If you have done your cutting. Is that correct or not? Yes? Now, what is that the sign of it? Again, look at it. Look what I put here. I put here plus. Why? Because the action was positive. The reaction, the action is negative. The reaction is positive. So I put here plus. This one, the action is positive. The reaction is, so this gets a negative. Is that correct? Yes? Now we go to there. But what happened suddenly here, I have written this. This was a singularity function. Yes? Singularity function was like that. Doesn't matter. It started here, go like, this is the linear. Is that correct? Or parabola? It doesn't matter. But I never ended it. Yes? So what I have written there, what do you think this means? This means ends here, or it means going all the way to the end? It means all the way go to the end, because this function beginning was set. The end was not determined. Is that correct or not? This function starts at A, ends at C. This function starts at A, ends all the way. Yes or no? Therefore, as if I'm doing this. So everybody please do that. So this is what you have written there. Is that correct or not? But that's not your load. Your load ends at C. So geometrically, what should I do to get rid of this part? I should counter put load there. So in other words, this represent start at A, go all the way to the end. I have to subtract this much. Is that correct or not? With the same intensities. Intensity of that is 2. Form of it is parabola. Yes or no? But this time, where does this one start? It doesn't start at 0. It starts at 2. X minus 2 to the power of 2 over 2. Is that correct? And the sign of it. Since this is negative, obviously this should be positive. Or the action is negative, the reaction is positive. So what's that? So you make one adjustment and that's it. Is that correct or not? So that's your loading. So you add this much and you subtract this much. Everybody understand that? Yes? Correct? This goes all the way. This starts at 2 and end up with the same intensity. So this together represent this load only. Is that correct or not? Yes? Geometrically, that's what we do. Correct? Because our function was continuous. Remember, I never end this. It's constant whether it's linear or upside. That was what linear. This was a parabola. We never ended that one. Is that correct or not? Yeah. Anyhow, so that's it, right? Now, we come to this one and that one. I'm not going to put it there. Can you tell me why? Would it make any difference or not? Let's put it there and let's discuss that, because for the other class I didn't put it. Let's put RB there. Now RB will be like RA, yes or no? So I put, first of all, I don't have any beam after that. Everybody understand that. So why do I want to put that? But let's say that we don't know that and I put it there, see what happened there. So I put plus RB, bracket x minus what? X minus this distance. That distance is 6 to the power of 1. Yes? But what's the idea of the bracket? Isn't that always the bracket, if it is negative, become equal to 0? Yes or no? So therefore, if this is x is here, 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 and epsilon if or before 6, this always become negative. Yes or no? At the maximum, x become equal to 6, still is 0. So always is 0. So why I'm putting there? However, this bothers some of you. You think that this will not come into equation. It will, but it will come in the form of when you are taking equilibrium scenario. So, yeah. P? What P? Oh, that's right. P. Okay, not finished there. So I'll have to put the P there. Yes or no? Correct? So then P become negative to that because the action is positive, the reaction is negative. So minus P, x minus what? X minus 4 to the power of 1. I went ahead of myself. Is that correct? So what I'm saying that, guys, this is what you should put in your note. The last two support or whatever you have at the support at the end, you should not put it in your equation because it does not affect your deformation. However, it will affect when you take everything into account because you have to do RA plus RB equal to load and all of that. Is that correct or not? Here, it becomes not relevant here. Is that understood? So the effect of this one and that one, because I have to put x minus 6, and x minus 6 is always 0. Yes?
So what if we started at point B and we went this way?
Then you don't put RA in the system. You start with MB, because some of your homework actually like that. You started with RB, MB, and then you can do that. Exactly, right. The last one, I said the last one, not the beginning. The beginning. Yes, if you started from the other side, everything goes in except RA, obviously. Is that correct? You put it there, is 0 anyway. Put it there, you're just writing it more, but it goes 0, 0 all the time. Is that correct or not? Yes? So that's it. Rather than previously, what did we do? I mean, previously, if we want to solve this not with the singularity method, we have to do this. Between A to C, between C to D, between C and we have 1, 3 unknown here, 2 constant here, 2 constant there, 2 constant there, 2, 4, 6 pre-star is 9 unknown, and I needed 9 equation. Theta 1 equal to theta 2, y 1 equal, which is not practical. Everybody understood that. You had, even in previous homework, you had only 2 span beam. You know how much math you have to do. Is that correct or not? Yeah. So this is the method being used actually for this and future for computerized system, because that's how it's being established like that. So the next step, this is your moment equation. Correct. Sometimes some of this. So you are here. You only use this one and that one. Everybody understand that. You are here, you are using this one and that one. Because you are here, you use all 3 of them. Everybody are 4 of them. Is that correct or not? So depend where you are, the system changes. But covers the whole range up from A to B. Yes or no? The next stage is now integration. So look how simpler this is compared to the other one. The P was 12, so let's put there 12 as well. So I can do it with the terms of P and W and L, or I can do it in the form of number. Notice that still RA is not given to me because I cannot solve this by a static alone. Everybody understand what I'm saying? That yes? Don't make the mistake that some people did in the other class. So anyhow, so EI theta, there is only one y and one theta, become RA x minus 0 to the power of 2 over 2 minus 2 x minus 0 to the power of 3 over 6 plus 2 x minus 2 to the power of 3 over 6. As I said, do not divide that. Keep this in the factorial. Minus 12 x minus 4 to the power of 2 over 2 plus C1. Correct? Just integration is simple. EI, the next one is EI times y. This is EI dy by dx. dy by dx is theta function. Then integral of theta is y. That's how you double prime, y prime, and y. Is that correct or not? Equal to RA x minus 0 to the power of 3 over 6 minus 2 x minus 0 to the power of 4 over 24 plus 2 x minus 2 to the power of 4 over 24 minus 12 x minus 4 to the power of 3 over 6 plus C1x plus C2. As you see in this technique, for this problem, if I have chosen the old method, it would have been very difficult. In this method, all I see here is RA as unknown and C1 and C2. So if I come up with 3 equations or 3 boundary conditions, I should solve for those 3. Is that correct or not? Yes, I don't have to go to 9 equation, 9 unknown like before. So this method is much simpler. Yes or no? Now, think that you want to write in your note. Notice one thing I have done here that you want to write it down. The system is like that, guys. The system is k x minus a to the power of n divided by factorial n. What I'm saying that in this method, I can integrate that and differentiate that the same way as where we were doing it before. So what I'm doing here that I don't know whether you notice or not, this is what I'm saying, that the d by dx of this function is equal to what? Is equal to n, k, n times k x minus a to the power of n minus 1 divided by n factorial. Yes or no? X3 becomes 3x2. Yes or no? That's what I wrote. And the rest of it, I said n k x minus a to the power of 1 less. Is that correct or not? Because I'm differentiating, correct? But look, this n and one of this n drops out. So this become what? This become n minus 1 factorial. So it works. Is that correct or not? Yes? And the same thing with the integration. With the integration, integral of that bracket, x minus a to the power of a over n factorial dx. So this is integration. The way I've written it is this. So it becomes k bracket x minus a to the power of n plus 1 divided by n plus 1. We already have n factorial there. Is that correct or not? Now, n factorial multiplied by n plus 1 already is n plus 1 factorial. Yes or no? So since this becomes n plus 1 factorial, and that's exactly what I'm using that. Look, 2 here become 3 over 6. This one become whatever we have, 3 over 6, 2 over 2. Everybody understands it, the same technique. So it works. Is that correct or not? Yes? However, let's finish the problem. So that is the technique we are using. In other words, all the terms can be integrated here with the same format or could be differentiated. Is that correct or not? With the same format. However, you don't need to worry about that. It's written right here if you follow the rule. Now coming to how to calculate value of C1, C2, and C3. Of course, this purple line tells you what to do. Is that correct or not? At x equal to 0, y equal to 0, yes or no? Because you have a support here that if support was not there, this beam would have gone up and down, yes or no? So whenever you see a support, that's your boundary condition. Is that correct or not? Therefore, at x equal to 0, y equal to 0, that means in this equation, you put x equal to 0, 0. Now here, you have to be careful here. This is x equal to 0 becomes 0, yes or no? This becomes 0, this becomes 0 minus 2. But what is minus 2? Minus 2 also is? No, it's not negative. Be careful. Yeah, it is negative, yes, but the result of the bracket, because this is not a parenthesis, this is a bracket, we told the computer to make it equal to 0. If negative, yes, it is in that respect, yes. It is negative, but negative is 0. I don't want you to calculate minus 2 to the power of 4. If you do that, you're ruining the whole thing. Is that correct or not? Everybody getting the point? So when it is negative, it's 0. It's 0, and this, of course, is 0. As the result, C2 become equal to 0. C2 is actually the initial moment. So therefore, C2 equal. Not always this is true, though, so you have to be careful. Now, next one is this. At x equal to 6, theta equal to 0. Is that in this equation, you have to put x equal to 6, 6 minus 2 become 4, then you become parentheses. Yes or no? 6 minus 4 become 2. It is plus, so it becomes parentheses plus C1. I write that result there because I'm not here for you to do the math. I put the result of that. Then you put this one, x equal to 6, theta equal to 0. You get this equation as the result. You get 36 RA plus 6 C1 become equal to 102 plus 67. There is a unit, we don't worry about unit, we put it at the end. That's the equation of putting in this equation, putting x equal to 6. Of course, my next boundary condition is what? At x equal to 6, y equal to 0, yes or no? Correct? Because I have a moment there or there. So I can write it here because this is easier. Let me write it down. I wrote, once again, I'm writing it here. At x equal to 6 feet, theta, I wrote theta first. Theta equal to 0 gives me this equation. 36 RA plus 6 C1 equal to 102.67. That's correct. Then at x equal to 6 feet, y also equal to 0. Then I have to put it in this equation, which is, but remember, C2 already gone to 0, so it again becomes another equation between RA and C1. So you see how simple this is compared to the other method. So here we get 18 RA plus C1 equal to 74.67. And then you solve these two equations for two unknown. Is that correct or not? RA and C1. So if you need the deflection at any point, you need the value of C1. So let's calculate the C1. C1 become equal to minus 11.67 Kipps foot square. We went through the and then you put it in one of this equation. RA become equal to RA become equal to, where is that? Somewhere here, 4.8. 4.8 Kipps. Anyhow, RA become 4.8 Kipps. Now, the first step of the work is this. If you want to design this, now you have to calculate RB and MB. Everybody understand that? What's the question back there? Here, at x equal to 6, theta equal to 0, and y equal to 0.
Yeah, so in the equation, it's
These two equations?
Yeah, y equals 0 is when it's C1x. So when
Where did I get this one? At x equal to 6 feet, also y equal to 0.
yeah, but it's xc1, isn't it? So shouldn't it be? It's 6c1.
What do you mean that? No, I simplified it that. Oh, you are talking about this one? No, I just multiplied, but because there are some common factor there. I've simplified that afterwards. It's not just one term. I just divided by 2 or whatever. Yeah, I understand what you are looking only at the first term. Yes or no? No, I simplified it. You know. So it could have been 36, then I divide everything by 2. Is that what you are saying? Okay, don't worry about it. That's the correct. Is that all right? Yes, see, he's looking only one term. You see, I'm putting here. Actually, it is could be. He's right, because 6. That's 36 RA. Everybody understands. But there are more terms here. I divided by. This is the simplified version of that one. Is that correct or not? Yes. Mm-hmm. Okay. Believe me, that's the case. So RA equal to 4.8. Since this, you can multiply by 2. That 2 multiply by 2 again. Okay. Because he's worried about it, think maybe there was a mistake. No, it's not a mistake, I'm sure of that. Is that correct in this case? Just you want to make it as simple as possible. Yes or no? Correct? All right. Anyhow, the question is, I solve for RA and I can calculate C1. Now everything is solved. If I have C1, I can calculate the deflection at point C. I can calculate deflection at point D. But remember the same technique here. If you're looking for deflection at, let's say, point D, now, this one is 4. This one is 4. This one is 4 minus 2. This one become 0. Everybody understand what I'm saying? If you are looking for deflection at C, this one is there, because that's 2. You have to put 2. This is 2. This is 0. This value is negative, which is 0. Everybody understand? Don't forget that rule. Used to become 0. Become 2 minus 4, it's minus 2, but it goes away because that rule applied. Anytime the bracket is negative, you set it equal to 0. Is that understood? So you can find deflection anywhere. You can find theta anywhere. Of course, deflection at that point is 0. Theta at that point is 0. You can calculate theta A by putting x equal to 0 all of them. Most importantly, the static of this is solved. Is that correct or not? Now that I have RA, can I calculate RB and MB? Of course I can. That's very simple. You add the load together. 2 times 2 is 4. 4 or 12 is 16. This is 4, 8. So this must be the balance of it. Is that correct? 16 minus that, which is everybody can do easily. So 11.2 Kipps. So please write down that. Then it comes to MB. Coming to MB, you can take the moment about A or take the moment about B, correct or not? Yes, and find the MB. MB ends up in this format, ends up to be equal to minus 15.2 Kipps foot. Means the direction that I have chosen is incorrect. Is that correct or not? Yes? But you have to commit yourself to a certain direction. Is that correct or not? Yeah? Did we solve this problem? Yes. Now, the question that a couple of people asked me during the office hours was this, that sometimes the book or the solution manual goes to negative. Now, what I want you to do is this, or I never advertise that. I don't ask you to do it because I want you always to start with moment, and it is easy really to do. However, the derivative of m is shear. Everybody understands? So this 1 become 0, 2 become 1, and 2 become 1, 1 becomes 0. But what is the derivative of shear? The derivative of shear is W. But this 1 becomes 0, then it becomes -1. Everybody understands? They look at the -1, they are surprised. I said, no, this has been done for the purpose of computer programming. This is not 1 over x, because x to the power of -1 looks like x1. This is one less derivative. Everybody understand what that is? This is because of the bracket format, we are thinking that way. Is that correct? Then, by doing that, we can formulate everything and start always from W. But that you are not writing a program yet. You are not there. All you want to do for this problem, it is easier to start with m. You have less constant. Everybody understand. The only thing is required from you, know the shape of what each one of these causes as far as that, which every one of you answer me correctly. Either is a parabola or is a linear or is a constant. Yes or no? Correct?
So what will happen if you have like
that's my next. That's what I'm going to tell you next, because I asked you to do that, isn't it? Yes or no? That's my next part. However, now here comes the question that you raised. Absolutely. What happened if the problem is, remember, even for triangle, previously I told you for triangle, we are borderline. We can go double integration or we can go the direct method. Let's go by direct method this time. Is that correct? This is what you are asking, yes? Okay, so here is the beam, and here is the load, but ends there. This is 6, this is 3. What did I have here? I have one example. Yes, I know that you are going to ask that question, and that's because I asked you to do some of that question. This time I'm going to go to the determinate beam. Notice this beam is determinate. Is that correct or not? Notice there is a fixed support there. There is no support here. Everybody understand that. Therefore, you can always solve for the reaction. Okay, if this is 6 and this is 3, everybody see what I'm talking about, and this is 3. This is similar to problem number 599 as far as the static of it goes. When we find the deflection, then it becomes chapter 9. Everybody understand? Yes, this is a question. How do I write this if I want to use that method? And the load is like that. Very good. Is that correct or not? Yes? First of all, how much load do we have here? 3 times 6 is 18 divided by 2 is 9. Where do you put it? 1/3. So the reaction here is 9. Is that correct or not? Yes? And the moment is 9 times what? 9 times 4, 36. That's what it is. Is that correct or not? So static is determinate. So there you go. As soon as I put another support here, it becomes like that. Everybody, and then it becomes indeterminate. Everybody getting the point again? Is that correct? Then I cannot solve it. Correct? Yes? However, this is a determinant part. I'm only answering your question. How do I write W as a function of x? So this one, let's say that you are interested to find deflection at A or deflection at B, 0 or deflection at C. Yes or no? If that's the point, correct? Mm-hmm. How do I set up my system here? Now, instead of double integration, now we go to direct method. So direct method is EI d4y over dx4 equal to W as a function of x. This is downward, so I want to put minus. So we put it afterward usually. Let's put W, we generally call it fx. In this case, wx. Is that correct or not? Yes? Now, how our W is being specified here? Now, is W what? Is the W a linear function? Yeah. Yes, correct? So which one should I use? 0, 1, or 2? I should use 1. It's linear. So how do you write this line? This is your x and y, or W versus x. Is that correct? How do you come up with that equation? That equation is kx. Is that correct? Yeah. K is the slope. We went through that. So it is 6. It is 6 over 3 with the unit. Is that correct or not? Yes? That's the slope. X minus what? X, where is it starting? 0 to the power of what? 1. You just said linear. Linear 1. Yes? Parabola is 2. Constant is 0. Yes or no? As simple as that. Yes, however, wait a minute, it's not finished. Just don't get ahead of me. Don't ruin my lecture. Yes? Don't be anxious, okay? We are getting there. However, when I did that, that's what he's saying that, he wants to say. I'm joking, of course. That means when I started here, again, I'm not ended. So that means I have gone all the way here. Is that correct or not? Is that what you want to say? Yes or not?
No.
Okay, so what do you want to say?
It's supposed to be negative, right?
Oh, yeah, negative, I said that, yeah. Sorry. I thought you was going to ask that question. All right, you have one point for your quiz. You got me there, all right? Okay, so minus, of course, minus. Everybody understands, because the load is downward, is that. If I put it in that format, means they are going up. Is that correct or not? Yes? So minus there. Now, I thought you were going to ask me what happened to the rest of the, because like there, when I start here, I cannot finish it. It has to go all the way to the end. Yes or no? Now I have to subtract this section, this trapezoid shape here, which consists of one constant and one triangle. Everybody says you have to turn it into what we know. Is that, or what shape I have given to you? But that is, if this is negative, obviously these two become plus, because we go all the way in and then we subtract. I'm not drawing that, but you understand what I'm saying that. Yes, when I'm subtracting, the effect becomes reverse. Yes or no? So the other one becomes plus. But this one is constant, with the intensity of how much? With the intensity of W, which is 6, times x minus what? X minus 3 to the power of 1? No, it's constant. To the power of, be careful, constant is 0. Is that correct? Linear. Because this is load. You are not writing the shear, you are not writing the moment, you are writing the load, it is linear, constant, linear. That's all you need. Is that correct? This is W. It has nothing to do with the shear and moment yet. Is that correct or not? Yes? Yeah.
So we add the extra part because after the linear, then
It's a trapezoid, yes.
then it's just constant after that. Is that why?
No, I'm not doing that. No. This has gone all the way to here. Yes or no? This part has to be subtracted. But what shape is that one? Here is 6. Here, I don't know how much it is. I have to calculate that. Yes or no? This become 6, and this become actually 12. Is that correct or not?
Oh, okay,
Yes, did you get it? So, but when I want to subtract this trapezoid, or you don't have a shape for trapezoid, but trapezoid is a constant plus a linear. Is that correct or not? So I'm subtracting in two parts, this part and that part. Do you see that?
Okay.
Okay, got it? Everybody with me? Yes.
Could you explain why it's to the 0 power?
What?
Why is it to the 0 power?
X minus 3 to the 0.
This one?
To the 0.
Oh, because it starts at this point.
Okay.
So that's the whole point. This is the A point. The A point is the starting point. If you have to go back to the last week, see, this is what I said last time. I want you to go back again. You see, this I don't want to repeat that. If you have a line here, that line y, let's talk about math, calculate. You have it there. I'm sure you understood that. You have to just put it together. Listen to me anyway. So here, this function y equal to kx. Is that correct or not? Yes? But what is this function? If this distance a, what will be that one? You know the answer to that. Y equal to what? K times what? X minus a. So wherever that, it doesn't matter whether it's a constant or was a linear or a parabola, I have to put a there. Is that correct or not? That's what we were doing. Look at that. All of that, this one is at 0. This is at 0. This is start at 0. These two start at where? These two start at 2. Is that correct or not? This one start from 0, goes all the way. This is not in a scale, guys. This goes all the way there. Is that correct or not? Now that I'm subtracting this part. Yes or no? But that part start from 3 goes to n. Is that correct or not? Anyhow, that's the answer. Then I have to subtract this part, which has the same slope. Yes or no? Again, plus what? The same format here. Plus 6 over 3, x minus what? X minus 3 again, to the power of 1. This is your load function, and then you can integral that. The integral of that become a shear. Is that correct or not? And then integral of that become, so let's go one step further. So actually you should not write it like that. I rather you write it like that. Erase that. I'm sorry, that's much better. Right. This is your W, yes or no? Then the next integral of that one is shear, which become equal to minus 6 over 3 x minus 0 to the power of 2 over 2 plus 6 x minus 3 to the power of 1 plus 6 over 3 x minus 3 to the power of 2 over 2 plus the value of constant value. That's what you were asking. Constant should be there. Or somebody was asking. Is that correct or not? Because a few people came to my office, asked a question about this system. Is that correct or not? Yes? Now then, one more integration gives me mx, which takes me there still. Everybody, after I do mx, then I go there. Is that correct or not? The rest of it is the same. But I have two more constant to worry about it. Mx become equal to minus 6 over 2, x minus 0 to the power of 3 over 6, plus 6, x minus 3 to the power of 2 over 2. Notice I'm looking at factorial. That way you make less mistake. So please follow the rule. Then to the power of 3 over 6 plus C1x plus C2. Notice this is equation of the shear. This is equation of the moment. I cannot yet use the theta and y, but I can use shear and moment boundary condition. Yes or no? What are my boundary conditions? Notice you can say many things. You can say at x equal to shear, at x equal to 6, the shear value is 9. Is that correct or not? This is, why should I use that, which I have it here? What's the shear value at this point? 0. Is that correct or not? Because it starts from 0, that is linear. So why not use that, which is much simpler? So for this problem, at x equal to 0, shear at point A is equal to 0 because it starts at 0. Therefore, look, 0 equal to 0, 0, 0 minus 3, 0 minus 3 are negative, so negative becomes 0, 0, everybody see what happened. Then C1 become equal, because when it is negative, it's 0 still. Is that correct or not? Don't forget that one. Although, look, I'm saying that, I see it in the final, I see it in the quizzes. You get a minus quantity, you square it, you are doomed there. Is that correct or not? First of all, you are doing extra work, and it's all wrong. Is that correct or not? The bracket, anytime the bracket is negative, set the whole thing equal to 0. I said it 5 times already. So look, again, this becomes 0, of course. This becomes 0 minus 3 negative, 0 minus 3 negative, everything 0. C1 become equal to? Obviously, there is nothing there. Is that correct or not? Then you come here, and then, again, at x equal to 0, also m equal to, because m at a equal to 0, there is no m there. Is that correct or not? Yes? So therefore, again, you put that 0, negative 0, negative 0. C1 is already 0. C2 become equal to 0. So somebody said me in the book they don't write here because there is nothing at the beginning. That's what the reason was. So in the book they don't show it that way, but that's the reason. Always you have a constant of integration. Now, the only thing warning that I give you to you is that if one of your beam has this on it, that may not show up. That you have to add it from here to here. Everybody on that. It does not show in the shear function. Is that correct or not? Yes? You understand what I'm saying? It will not show in the shear function. You have to show it in the moment, because that's only affect your moment. That's why you have to be very careful what you are doing. Is that understood? Yes, I can change this problem, for example, to here. That's why I said start from M. Actually, if you have that one, most likely you are using this method. If you are using this, remember I showed you last time, this become a constant, yes or no? But that method, when you start from here, and somehow, somewhere here, you have another law like that, you have to be careful to add that to your moment diagram. Is that understood? Is that correct or not? Yes? So be careful what you are doing. Anyhow, this now 0, 0. So now this goes there, and then rest of it is the same. I don't have to do it. Is that correct or not? Correct? All right, guys. So now, did I answer your question? Yes, that. So anytime the load is much more complex, you can use this method. especially if it is continuous. Usually this method is for continuous function from beginning to the end. Of course, for triangle, this method for this system is simpler. Is that correct? Although, remember, I did that once before for you. You can find the moment as a function of x as well. Is that correct? Yeah.
What about a parabolic function?
No, that definitely you go the direct method. Actually, this is designed for any function. Notice that you have to put it there, you have to intake, but the integration has to be performed by computer, not by hand. So that's what it is. But the system works. That's why, if you are asking me, yes.
I mean, what if the loading is parabolic and ends
Then we may have to do it. I have to look at it. We have to do it in two parts. Yes, part A and part B separate. Depend. It is that way. You have to go beyond what we are talking about here, but it is doable. Yes.
How'd you find that last term plus 6/3?
What?
6/3, the last term?
This one?
Yes.
That was. You see, this is constant, and this is again is a linear, or I have to subtract these two.
Right, but how'd you get 6?
6/2 because this has a slope of 6/3 again. Because that's the same line. If that line here has the slope of 6/3, this line will have the slope of 6/3, correct? Because that's the same line. I didn't change that. I draw it badly, but it is the continuation of the same line. Yes. Sorry for that. Yes.
I'm just wondering, haven't you changed the system when you add all that load?
No, I didn't change anything. Mathematically, that's the same.
Why, so you don't,
Come on, guys. So I did not change anything. I'm going to erase that. You are asking a question that should not be asked because, first of all, these are linear. Everything can be added together. This is what I'm doing. For that load, let's put it back again. I don't know why you are asking that question. This is equivalent to, let's do it higher because it goes to 16, is equivalent to that. Yes or no? Minus this minus this. Now add this together. Yes or no? Is it the same thing? Yeah. So what am I changing? What did it change? I don't understand the question. Let's put it this way. So if I have this load now, you see that? Which was represented with first term. Yes or no? Then I have a constant of 6 going upward. So I have to subtract this going in, this coming out. Yes or no? Yeah. And this has gone in, this has come out. It's the same format. That is the same as this one. It's the same slope, the same thing. Is that correct or not? The same area. Yeah. That one is going down. This one is going up. Exactly the same shape in reverse. Is that correct? So what has changed? Nothing has changed. I add and subtract. I can do that. Yes or no? Because the deflection is linear. Is that correct or not? I don't know what is in the back of your head. Again, mind you are asking that question. What are you thinking of? Did I add anything? No. Did I sub? I just did to get that shape, back to that shape. Yes or no? Right. Now you can play with it. Actually, this is some game that you can play and you can you can have any load you want to by adding and subtracting. It could be a beam like this, for example, and then put a load, I don't know, whatever. For the other class, I said something like that. Is that correct or not? Yes? All I'm saying, that makes it look to something that you already know. What you know is a constant load or a linear load, because that's all you have. Is that correct or not? Yeah. Of course, you have a parabola one, but parabola is difficult to work. Parabola, as you were asking. Yeah. Is that correct or not? Now, if I want to do that, I go one constant all the way. Then I go this constant, starting from here. That was your question. Start that from this point. Then I have to subtract this much because I have that much extra. That's it. So it becomes 3 terms rather than. Yes? So you, by adding and subtracting, you can go there anyhow. So is that understood now? So now you can do it with 2D problem. I mean, for determinate problem. For indeterminate problem, you can play with it any way you want. You have to add, but what is important is recognizing this shape. Everybody, again, one more time. Constant, linear, that thing is come from your knowledge of how to do the moment diagram. Is that correct or not? Yes? Any more question? I don't want any question. Anybody, everybody is okay here, yes? Hopefully? Right. One thing is not avoidable again is that recognizing what each one of these do to your moment diagram, which I already discussed it. I'm sure you know it. This one is linear. This one is a parabola. That one is a constant as far as the moment is concerned. Yes. As far as the loading is concerned, you just have to express your load as a function of x. That's that function. That's it. The shape of it. By adding and subtracting if it is terminated at some point. Is that correct or not? Yes? You can do anything you want. There are so many things you can play with it that this is all math actually. It's like a sort of puzzle. So you have I gave you previously a problem like that. Yes or no? Correct? Look, can you go all the way like that and then subtract this one from it? Yes or no? Yeah? Play with it. Yes, you will see. That's the same thing. So you add up because deflection are linear. In the next method, you will see what I'm talking about. Yes.
So this, right, when we have like a linear weight distribution where it's like 2 kips per foot, that would like essentially be like a giant bag of sand that you put
Correct.
on top.
Correct.
Now, this is assuming that the deflection of the object is matching exactly what the beam's deflection is, right?
Right, of course.
Now, is there like a mechanism of, I guess, simulating like a non-flexible object or like a less flexible object being on top of it? Like instead of putting a bag of sand, like you put a brick, and there's like maybe a non-continuous connection within the center, for example?
As far as the beam is concerned, are you talking about the object or are you talking about the beam? The beam is made of steel or concrete. It's going to bend regardless of the weight anyway.
Yeah, but
so the weight going
the
down.
The object won't necessarily be in contact along the entire.
Oh no, no! I see what you mean.
Or at least
No,
it won't
we are
necessarily
assuming
be
that is going to follow the beam. But these are such a small quantity, you should not worry about that. If that's what you are saying, this is not visible even with eye. This deformation, as you see, the key really to the problem is not the amount of deformation; it's solving the static of the problem. Notice that all of this is geared to solve, if it is become indeterminate problem, is a static of the problem. No, we are assuming all of this is small deformation and all of this with it. That way, first of all, if the beam, if these are attached or sitting, if it is one piece, then that's a different story. You are saying that that's going to be a somewhere contact length. Is that what you are saying?
Yeah.
No, that's very, very, very difficult part. You have to go.
Not necessarily that it wouldn't be continuously, like, just that its rate of deflection would be different from that of the beam. Like, it would still deflect, but it would deflect at a different. Have a different
see, you are giving some theoretical. I mean, the beam is going like that, and this is contact. Let's say this is the contact here. Then you don't have to consider at a continuous load. You have to consider at one weight at that point of contact.
Okay.
Correct?
Yeah, but okay.
No, but it is not like that because it is not like that because this deformation of so small that body which going to deflect like a beam because these are such a small quantity and we are assuming the elastic difference between the two is not enough to do that. Is that correct or not? Otherwise, the beam will not behave like that. You are right. If that changes, the system changes, the loading changes. We are assuming this is the sack of cement and continuously leaving that like a weight. See, weight is a constant thing. Is that correct or not? All right. Now, let's go to the next method. The last method is the superposition method, guys. And this is really very simple. At the same time, is interesting because this opens, again, the gate of lots of solution for you. But you have, again, get the idea behind it. Now, what's the superposition method is very important. So let's say we have a beam here. Again, the same idea. Let's say that I have here a load P, and I have a uniform load of WO, and the length is L. Now, we are using this time superposition method, which is the last set of your homework, superposition method. Now, the superposition method works only, write it down, if the deformation is very small, as I was referring to. Deformation must be very small, write it down. And also, they must be linear with respect to the load. they must be linear with respect to the load. In other words, when load double, the formation become double, correct. That's what linear means. Is that correct or not? That is why I erase everything here. If you go back, look at all your homework from ME 218 and 219, you will see that theta and y and w and we are always is linear with respect to p and w. Everybody, we never saw square root of p. Have you seen any time using a square root of p? No. Did you use a square root of w? Did you use w to the power of 2? If that's the case, the superposition would not have worked. Everybody understand that. Remember, next week we are going to go to a system that superposition does not work. For all the beam and the method that we use so far, superposition work because first of all, the formation are very small, remember that. And second, they are all linear, write it down. There are some other condition which is secondary. The beam has to be homogeneous, this and that, but that's not important. As far as our concerned, that's the only system that we want to use. Now, in that case, I can break this system into two systems. I don't know whether you noticed or not. That's what probably you were asking. I don't know what was this is a question. I said this beam, the result of this beam is equivalent to this and this and that, yes or no? That's what you were worried about, yes or no? But the superposition works. Is that correct or not? Because they are all linear. So when the load double, deflection double. If it is half the load, deflection half it. For that reason, that method works. If it was not linear, I could not use it. You are right. Is that correct? You see lots of x to the power of 4, x to the power, but never w to the power of 4. You see, if something is related to p squared, then p is 2. P squared, when you 2 times 2 become 4, but 4 times squared becomes 16. Everybody understand what I'm saying? Will not work. But go back, I will show it to you in a minute when I put the table on the board. Is that correct or not? Yes? Therefore, this is done. What I'm saying that with the superposition method, we break that into two beam. Let me finish this, then you can ask question, because probably I am going to answer your question. One like that, I put a P here, plus this. Let's put this point A, this point B, at the middle of that point C. I can put even number there if you want to for just simplicity. So let's say this is equal to 6 kips again. And let's say this W equal to 3 kips per foot. And let's say that this is also 3 feet and 3 feet. Question is this, guys. I want you to calculate y at B. This is the question. Theta at B. And I want you to calculate y at C. For this beam, I want you to do, but I don't want you to use the previous method, because previous method is writing one of the method. Is that correct or not? Either singularity function or double integration, etc., cutting here, mx here. I use superposition method. The first question come to your mind is this. If I broke it into two systems, system 1 and, as we were doing here, remember that becomes suddenly 3 systems. Is that correct or not? Or adding the result together. As everybody can notice, at least as far as the statics is concerned, if P is 6 and this is 3, 3 times 6 is 18, 18 and 6 is 24. I have 6 here and 18 here. The total is 24, yes or no? The same thing with the M, the same thing with the theta, the same thing with the Y. But the only question is, you will say, okay, I had one problem, now you change it to 2 problems, yes or no? But that one is going to be answered by the following. Okay, let's see that this is on, and this is down, so let's put it down. I hope I said yes, it's there still. Is it on, this one? Should come on in a minute. Takes a while. It's showing anything there? Yeah? Yeah, you can see it. Yes? Look, something I did not reveal to you before is this. Sorry to say, you work so hard to solve all the determinant problem. The solution of all the determinant problem is in the book. Sorry for that, because that is how it works. Look, I have the solution given for this beam, this beam, this beam, this beam. Everybody understand it? It's in the appendix. Not even that. If you are smart enough, you solve that in terms of W and L once. You put it in your calculator. Every time I ask you that question, you will just change the W and L. Yes or no? Yes? So that's what it is. Look how this becomes there. Let's calculate. I want to calculate theta y at point B. This is point B. This is point B. Is it given in the table? Look at it, guys. Is that what? That's what all I'm saying, you guys. Look, this is the first beam. Yes or no? This is the second beam. This will be given to you even final in the thing. Then from now on, I don't ask that question from now, because that is childish question. Yes or no? The real question are indeterminate problem. Everybody understand? The determinate problem, who cares? You solve it once, you put it in your database, you have it forever. Is that correct or not? Yes? You just change the value of W and EI and L. These are the solution. What is this they are showing here? Look here, maximum deflection is your concern. How much maximum, because the rest is less. Maximum slope, what is that? Equation of that curve. Everybody see that? That is being done. All these things for different beam, you can have 10 of them or you can have 100 of them. Yeah, everybody understand that. All you have to do, add now this one to that one. Yes? Okay, read it for me. What's the maximum deflection? Look how simple this is. What's the maximum deflection for this beam? Can you see it from that corner, guys? Can you see it there? Can you see it here? Or should I write it over there? Yes? Okay. So let's write YB. Okay, sorry, I have to write it here. YB equal to what? YB of this system equal to YB of system 1 plus YB of system 2. Okay, YB of system, you have it there. I cannot read it from there, but you can see it there. What system 1 is minus P. Is that correct? What's the value of the P? 6. Minus 6 times L to the power of 3, yes or no? Yes? What's L? L is 6. 6 to the power of 3 divided by 3i. That's it, guys. Finish. Yes? Plus, of course, y of system 2. That's for system 1. Is that y of system 2 is also there. Is that correct or not? This one, okay, this one is there. Is that correct or not? And it's negative. As you see, it's going down because its slope is that. So minus w. This time w is 3. Length to the power of 4, which is 6 to the power of 4, divided by 8 EI. Now, one thing you have to be careful here that sometimes students panic rightly is this. They see here L to the power of 3, and they see there L to the power of 4. They think this doesn't have a unit, conformity with the unit. Everybody, it is correct. You know why? Because what is this? 6 is kips. 3 is what? 3 is kips per foot. So the unit works. Everybody understand what I'm saying there? Yes? Because those 3 and 6 have unit in them. Is that correct or not? So all I'm saying that, add these two together, you have the answer. Is that correct? That's the answer for y. As simple as that. Yes or no? Of course, it's not that simple. We can make it a little bit more difficult. Yes? Let's calculate theta at that point. What's the theta? Is this the maximum theta? Look, maximum theta is there. Is that correct or not? Yes? So maximum theta is this two. So if I want to calculate theta b, these are all become one-liner. Theta b is equal to. I add theta. In other words, this beam is bending like that. This beam is bending like that. That was quantity 1. That was quantity 2. Is that correct or not? For theta, I have to calculate this theta, add that to that theta, but it's given there. Again, the superposition work. Look at it. This is what I was saying. Look at this. Look, one more time. Look, the deflection is in terms of P. Yes or no? It's not P squared or P to the power of 2. Everybody see that? So if P doubles, the deflection doubles. That's what we were talking about. Look at this one. This is elastic curve. Look at the P. Look at the W. Look at the M. Everything is linear. Yes or no? If it is linear, then superposition works. Everybody understand? This will not be true. I'm repeating myself. This will be not repeating itself for next week lecture, which will be energy method. Is that correct or not? Everybody getting the point? Because energy is not linear with respect to load. Doubles energy become 4 times. We will see that when we get there. Is that correct or not? This is only for this one. Now, do I want to theta? So all I have to do for theta, add this one to that one. I'll have to plug in the number. Is that correct or not? Let's do that. So theta b equal to how much? Theta b become equal to minus p again is 6 times L to the power of 2 divided by 2 EI from the table. Yes or no? The first line of the table is there. Yes, I cannot show it there. There. Is that correct? The first one and second one. And the second one is minus 3, 6 to the power of 3 divided by 6 EI. Is that correct or not? Then you add it together, of course. Yes? So calculate. Now, how do I calculate? Y at C, for example. Look where the C is, guys. That's all you have to look at. Where is the C? You see, is this given here? No, it's given there, but it's given there. Is that correct or not? Is this the elastic curve? Yes. In that equation, what's the value of L? The value of L for our problem is 6. Yes or no? The value of P is given equal to 6. Is that correct? But L equal to how much? L equal to 6. Is that correct or not? But x equal to how much? X equal to, depend where you are. So in other words, you use this is equation of elastic curve that you were looking for every problem. Yes or no? That's your y. After all the integration, etc., etc. The result is there. There is nothing to worry about it. Now, why did I do that for you to go through all of this? You will not understand all of this until you learn the technique. Remember, some of you eventually may end up going to graduate school or go to the PhD or going to become a scientist. I don't know, whatever you want to become. Remember that. Then if you want to, you have to know all the detail. Without the detail, I cannot suddenly put this in front of you and say, solve it. Remember last time when we were designing a shaft, I gave you one equation at the end. Yes or no? What do you think their equation came from? That equation came from all the 7 steps that I put on the board. Means I use this Bohr circle. I use the idea of failure theory. I use the theory of failure about the shear. I use in-plane shear, out-of-plane shear. Everybody understand? Everything you learn in ME 218 and 219 were in that one equation. Everybody understand that? That is, you will get some of those in future for certain simple problem, because they give you a formula. They say this is the design formula. Everybody understand? But they have gone through the same operation. Here is the same thing. From now on, you can use the superposition. You use somebody else's work, in other words, add it together, but you have not gained any knowledge. Everybody understand? My attempt was here to teach you where we are getting at. Is that correct or not? And that's where we are now. Is that correct or not? Nevertheless, that is your y. Remember, we are working y. Now, if somebody, this I forgot to mention in the other class, if somebody asks you what is theta at C, what do you do? Take the derivative, exactly. Take the derivative of that, take a derivative of that one. That's the theta. Is that correct or not? Which shows from the beginning of the beam to the end, from x equal to 0 to x equal to 6, which is the end of the beam. That's the equation. Is that correct? That's what you were working about. Remember the previous example that I did? I wrote the W, then we come to the shear function, then moment function, then theta function, and y function. Yes or no? So that's it. Is that correct or not? Now, look at the rest of the table. I want you to read the table together. Now I go there to the computer to show you that. This one, we already discussed. Yes or no? Correct? Yeah. This one we already discussed. This one, it has a moment there because you may have sometime moment. However, if the direction of moment changes, obviously you change your m from plus m to minus m. This is the solution is given. You have to adjust that. The next one is the load at the middle. You had one homework like that. I asked you to do half of it. Yes or no? Because it is symmetrical. Yes or no? Therefore, it's given here. The answer is given for half of that. The next one, actually number 5, is very interesting. The number 5, Load is not at the middle. Load is shifted to one side. Yes or no? So here is the scenario. Please make a note in your notebook because you have to be careful there. Now, let me go back again to the previous one. Now, let's go back to number 4. Look at number 4. Look at the theta. Again, I'm reminding you, look, theta should be the same. Theta A should be equal to theta B. Yes or no? But why two answer here? One is plus and one is minus. This one is minus. This one is plus because this is counterclockwise. I'm sorry, this is clockwise. Clockwise is negative. This is counterclockwise. Do you remember that or do you want me to specify one more time? Remember what I said last time? If you have a beam like that, doesn't matter where the load is. If at the middle, let's put it at the middle. If at the middle, this should be equal to that in magnitude. Yes, but this one, look, originally was like that. It has gone like that. So this is going clockwise, therefore is negative. But this one originally was like that. Now it is like that. It's gone that way. Look at that arrow. That is counterclockwise, therefore it is plus. This you have to be careful because it will apply to this one as well. So let's go back again. So this side is negative. This side is positive. Now we're going to the number 5, which is like that. Okay, if it is like that and the load is here, that's the load P. Notice there is A distance and there is a B distance. Be careful here. Make a note of that, even in your book or there in your note. Notice here it says A should be larger than B. It's somewhere here. Here it is. Do you see that? A must be larger than B. Otherwise, this will not work because, as I said, you cannot formulate anything, so you have to be careful here. Is that correct or not? This is only for A larger than B. In other words, if I give you a problem and A equal to 4 meters and B equal to 2 meters, that matches there. Yes or no? However, there will be a homework that I give you this load here and I put here 2 meters and 4 meters there. Everybody understand? Or any number, doesn't make it. Then what should I do? Of course, you have the answer. You flip this. Is that correct? No. Or you consider your X from here and Y there, everybody. But with one difference, though. Here, this theta is negative. That theta is, when you flip it, this theta becomes negative. You have to change the sign, everybody. That's why I'm explaining that. So you look at your picture. You decide whether theta is plus or minus when you add it together. Yes.
So I don't know what we can just draw this like a mirror.
Yes, Sika, that's exactly what you do here. Exactly like changing the sign is you do that. For example, this one, the moment is here. What's the difference? You can put moment there, but then theta changes. Is that correct? Theta A become theta B become theta. It's all logic. Everybody understand what I'm saying? That just use the mirror image, but follow the rule. Is that correct or not? So there is no really thing, but be careful here what you are doing. In this one, again, this is the first problem I did for you. Remember that at the beginning, yes? So this sort of thing, you can do that. Now, however, like the other class, still there is a little bit more, 10 more, 15 more minutes more of the actually a nicer homework that I want to do for you for this. Because superposition method actually is one of the best methods, I tell you, especially for mechanical engineering. Because we can do all the odd problem as well as the simple problem. Actually, we never use it for this. For this one, it's there. Is that correct or not? When we come very difficult problem, we are going to incorporate that into our system. But since I'm running out of time and I don't have time to finish that one, so we are going to postpone. I don't know whether I said it at the beginning of class or not. We are going to postpone your quiz and your homework until